Hello, if you're watching this extra video, it's probably because you're really curious about this child on the sledge question, where this child goes up the inclined plane and then comes down. Now, the actual past year question from summer 18 or May-June 18 is fairly straightforward, especially when they ask you to describe the change in frequency as the child travels from 4 to 8 seconds. But the problem here is, what if you are required to sketch the variation of the frequency along the entire track of the inclined plane? So the child will go up and then come down. So let's say he's blowing a whistle and an stationary observer is standing here. So the child will travel up. He starts blowing the whistle at point A, 900 hertz whistle, all the way up to B, and B back down to A. Okay, so if you've done the first part of the calculation, that's great. If not, you might want to pause the video, do that first. This is from May-June 18, paper 22. Okay, so try that question. And you go and find that in the description link. We are going to fast forward to part F, where we sketch the variation of the frequency of the whistle. Because when you think about the child and the sledge, right, when the child is moving up the sledge and blowing a whistle at the same time, the child is slowing down. So the frequency, while there is still Doppler effect, the frequency is unlikely to be constant. So let us take a peek at the equation first. We all know the Doppler effect equation, and we are pretty familiar with this. It looks like this, right? For some variations, the source frequency will be multiplied here. Normally, we will take plus if the object is traveling away. So if the observer is standing at A and the child is moving away, we will use negative if the child is moving towards. But for this particular special case, because we are going to substitute Vs with this graph. So of course, if you're at this point, you're kind of like curious in maths, right? So I am actually substituting a function. And this function is the equation of the straight line. So you got negative 1.5t plus 18 derived for the equation for this straight line. And this straight line is negative 0.5t plus 6. Okay, you don't know how to find equation of a straight line? I guess DM me, okay? I just want to keep the video pretty brief. So here and here is different values of the equation of velocity at different domains or different time period. From 0 to 12 seconds, the child is traveling at this velocity. From 12 to 24, it's traveling at this velocity. So we are given the speed of sound and the whistle frequency, and you are asked to sketch the F against T graph. So now I already have the equation of the straight line, so I will put here. So you can see from this derivation that I will substitute Vs. But you will notice that in both applications, I didn't use the negative sign. And the reason why I never used the negative sign is because, number one, I've used the Vt equation. And this Vt equation and the entire graph is taking up the inclined plane as positive. So this one is always positive already. Because from the equation perspective, you're always traveling away. So from the equation perspective, when you're traveling away, it's positive. When you're traveling towards, it's negative. So that's why we maintain the positive sign on both sides. And you will see that it will make sense once the graph appears. All right. So we're going to substitute this negative 1.5t plus 18 from 0 to 12 seconds into the equation, simplifying it and getting this. Repeat the same process for negative 0.5t plus 6 into the equation of Vs, simplifying it and getting this. But now you might be a bit stuck. How on earth are we going to sketch this graph? I would like to invite a distinguished further maths lecturer to continue this part of the lesson.
Okay, so I am told to do some stuff here to sketch this graph.
Yes, thank you. How?
Okay, so let's just start with some observation. Okay, so before you start test this graph, okay, of course, the method one, you can just find a few points. Yeah, find a few points. This is very standard method in general. Okay, so okay, we have a function like this. Okay, let's just take the function first. Fx. Okay, ft. Let's just follow. Okay, ft equals to this. Okay, I'm gonna call this number k. Okay, because they are very annoying. Okay, so k 3.5 this minus 1.5t. Okay, this is when this
time is 0 to 12.
Yeah, from 0 to 12. Okay, and then from 12 to 24. You have something else. K over 3, 4, 6 minus 0.5t. Okay, so usually you can choose some nice number, I guess. Okay, for example, you can choose you can calculate F0, okay, which is basically K over 356. Okay, you can calculate what the value is. Okay, and then you can maybe do like F. Okay, pick some number in the middle, maybe like for example 6. Okay, then this is K over 6 times 3 by 1.5 is 9. So this is 349. Okay, then you just get something else. Okay,
Sir,
whatever that is.
I
Yes.
draw the VT graph already. I can directly read the values from the graph, right?
Which one?
Nah, the graph.
Here?
Ah,
Sure, if you want to do that.
yeah. So that is,
I
I guess it's another
yeah,
option.
there's another way, yeah.
Hmm.
Okay. So yeah, okay, but whatever, you can find few points like this. Okay, find 12. Okay, because 12 is important, by the way. 12 is a critical point. 12, I think you have that's 6 and 3, 18. So that is 340. Okay, 340 is the critical value, right? Is that
Yeah. So
340.
340.
Okay.
So isn't the answer 900?
Yeah, this is 900. Okay,
Okay.
exactly, because K is okay. Let's just write here at the side to remind ourselves that K is 300 times 340 times 900.
Okay.
Okay, so this is nice. Okay, so you already got one very nice value. Okay, you can calculate a few more. Okay, F of 18, for example, and F of 24.
Okay.
Okay, so K over some stuff and some stuff.
Should I press calculator, sir? Should I press calculator?
Yeah.
Okay, hang on.
Okay, so you can get rough estimate for this value. Okay, I'm going to do calculation as well just to get a quick estimation. So now, okay, yeah, this 5 point is good. Okay, so let's just use the graph for example. Okay, I'm going to use a non-scale graph. Okay, so I can start from, for example, 850.
Good idea.
Okay, so let's say if F50 is here. Okay, so yeah, my graph is. Okay, you know what? I'm going to start at 850 here. Okay, and then here is 0. Okay, so 12. Okay, I need to count one by 1, 2, 3, 4, 5, 6, 9, 10.
So
11, 12.
I put nicely under the graph on top. Can just extrapolate. Kind of.
But the number of squares is the same, right? Is it the same?
Roughly lah. Cannot, right? Okay, we count. It's mathematics time, so have to really count 9 in maths. This is not physics.
Yeah. But okay, I guess in exam you have the bow line to help you.
True.
So that is much easier. But okay, you know what? Whatever.
In exam they will give you a scalar for physics. So if it's for maths, then you draw your own one.
Okay, so you can see rough difference here. Okay, so let me just write here. Rough difference is about. Okay, I'm just gonna do estimation, by the way. I don't really care too much on how accurate this is. Okay, because you can't really plot this point 854 like where on earth is 854. So and then this difference is about 22.
No, 875.
It's this difference. Okay, because you just minus here, you get 22 here. This minus here, you just get about 24. Okay, so the difference is about equal. Okay, and then here the difference is about 8.
Now one also about 8.
The difference is also about 8. Okay, so yeah, so we roughly know their difference is more or less the same kind of. Okay, so I'm going to plot these points. Okay, so I have a 900. Okay, this is an important line here. Okay, so maybe I'll draw like 2. Okay, so 860, 870, 880, 890, and 900. Maybe 900 I'll put here. Okay, and then 910 maybe somewhere here, and 920. Okay, so I just need this. Okay, so 900 and this 12 is here. Okay, this is 1 point. Okay, I'm just gonna label the point here first. I don't know what's the requirement for physics, but I'm just gonna put it. Okay, 854. So 854 is somewhere around here. Okay, and then 876 is. Okay, let me just 860, 870, 880. Okay. 876 is somewhere here. Okay, and then 908.
Around 910.
Yeah, somewhere here. And then next one is
916.
Yeah, so about somewhere here. Okay, so you can see. Okay, this part is definitely one graph. Okay, just be careful here. I'm going to draw first. Okay, and then this part is something else.
Different domain.
Yeah, different domain. Okay, so you can of course naively just join the lines.
Sir,
okay,
I very naive one, sir.
Yeah, so join the lines like this, and then you got join the line like this. Okay, I missed the line. Let me try again. Okay, and if you put your ruler down, you will see that they are actually approximately straight line. Okay, so let me just say these two. Okay, these two are approximately straight line.
Just a gentle reminder for physics, if you're asked to plot a graph, use crosses, okay?
Okay, so for both color,
they are both approximately straight line. Because we did approximated the difference, right? Is that why we're approximating it as a straight line?
Yeah. Of course, if you're not sure, you can get more. Okay, so for example, you can get like F3 here in the middle, F9 in the middle. If you just want one more point is good enough actually. One more point. Okay, maybe here you can get another F21. Okay, so yeah, I divide the thing into, okay, but it doesn't even matter what number you use. Okay, choose a number that's easy for you. Okay, so this is one good suggestion. Choose a number that's easy.
I think enough now.
Yeah. Okay, so this is how you plot the graph. Okay, but if you look at it strictly, you see that this is actually not
a straight line.
True. Okay, not really a straight line. Okay, in fact, what you're getting here, okay, is that you are having ft is actually some equation of this form, k over a minus b times t.
Ooh.
Okay, and if you recall how you do transformation, okay, we can start off with a simple
1 over
function.
t.
Yeah, 1 over t. Okay, we can start off with let's start with a function called gt equals 1 over t. Okay, so down here is your horizontal transformation. Okay, so horizontal transformation, you do this. Okay, let's do another. G a minus t, that will give you 1 over a minus t. Okay, let's call this function another name. Let's call this h3. Okay, this is what you usually do. Okay, let's use another function. Let's call, okay, I don't know what other name I can. Okay, let's use call okay, capital G. Okay, what I'll do is I'll just do h of b times t. And this is just a minus bt. Okay, and finally, of course, you can get another function, which is this. This is to take k times this thing. Okay, which is k over a minus bt. Okay, so what you do is you actually go through 3 transformation. Okay, so this one is a translation. Okay, translation by sorry, there's a reflection first. Oh, I forgot reflection. Yeah, there's a negative. Okay, so there's a reflection first. Okay, you know what? I'm not going to care about reflection. I'm going to do plus here first. Okay, I'm going to put negative here just to cheat. Yeah. Yeah. So we can cheat here. Okay, so I just put negative here, negative b. Okay, so here is a translation. Okay, this translation is negative a is 0. Okay, so if you look at original graph. Okay, so this is roughly how it looks like. Okay, very ugly. Here you translate by this amount, you get move to one side like this. Okay, yeah, so this is how I teach in class, by the way. For those who are in my class, I will do a sketch drawing here first, then later on I will do a nice one. Okay, and then here you scale it by a certain amount. So scale, you don't see the difference. Okay, so in general, you don't see a difference in terms of scale. Okay, you see just something like this. Okay, but there's a reflection. Okay, so the reflection will happen. Okay, so here is a reflection. Okay, so reflection here is that you flip this like this. Okay, so you flip on this axis. Okay, so your graph now will look something like this. Okay, and this line is actually when this thing is equal to 0. So if you look at both of your values, you'll see that, okay, so for example, first one is equal to 0 around 200 plus. Okay, so this is equal to 0 around 200 plus. Okay, and this one is equal to 0 around 700 plus. Okay, so both of this thing has a shape like this. Okay, so if I draw big enough, okay, let's just consider the first one. K over 3 358 minus 1.5t. Okay, so you do 358 minus 1.5t, okay, equals 0. You get t is actually equals to 358 divided by 1.5. Yeah, about 200 plus, okay, 238. Okay, doesn't matter. Okay, so our line here is 238. Okay, and then you have this thing over here. Okay, and then this part. Okay, but what we want is actually just from 0 to 12. Okay, so we only want this small little segment here. Okay, this small thing here. So if I zoom in big, zoom. Okay, this is the biggest I can zoom, by the way. Okay, I only want this little tiny dot here. Okay, so okay, let me just. How do I do, teacher? Okay, cheat. Yeah, okay, I only want this little blob here. Okay, so this little blob, if you zoom in very inside, it looks like a straight line. Okay, my thing is very thick. Okay, but it looks like a straight line like this. Okay, so in reality, this thing will go all the way up. Okay, my screen is already run out. Okay, and this part here will go all the way down. Okay, but so it looks basically just like a small straight
line. So it's a curve that we super zoom in that looks like a straight line.
Yes, it looks like a straight line.
Oh, it's like the Earth is flat because we super zoom in on the surface, right?
So that's why, right, our building can build on, flat faces.
Not like Minecraft, cannot have flat plan. On Minecraft, cannot.
Okay. So likewise, the other segment, okay, the other graph, it's similar. Okay, the other graph, okay, if I draw on the same scale, okay, so if I draw on the same scale, something like that. Okay, the other graph, what is the equation? 246 minus 0.5. Okay, so k over 246 minus 0.5t. Okay, so if you take 246 minus 0.5t equals 0, you get t is actually equals to 692. Okay.
92.
So if 692, right? Yeah. Okay. So if this one is 25, 600 is somewhere here. It's somewhere here. Okay. So your graph actually will look something like this. Also. Okay. So yeah, my drawing is very ugly, but we are just taking once again a small segment from 12 to 24. So in this whole thing, 12 to 24 is probably just one little blob over here.
So can we say that if we compare the top graph and the bottom graph is less steep than the top graph because of the multiple in front of t? Is that why?
Yeah, because this one goes, okay, you can think of it this way. Their crossing here, right, is actually quite close. Okay, their intersect is actually quite close. Okay, this one will go up faster because you hit this line faster. This one, actually, I haven't even hit the line. Okay, so yeah, it will grow slower a bit. But you can count gradient. Okay, yeah. So differentiation if you want. Okay, find gradient and so on. Okay, so this is all a lot of extra works already. Okay, to find gradient. Okay, so find f prime t. Okay, which I'm sure most of you know how to do. Okay, because we know that. Okay.
Yeah, it's a pretty simple function to find the derivative.
Ft is k times a minus bt to the power of -1. So f prime t is actually bk over a minus bt squared.
Okay.
Okay. So you see that which value is bigger, which value is smaller. Okay.
So no negative.
Where? I skip a lot of steps because there's a double negative.
Oh, okay.
So there's a negative 1 here and there's a negative k.
Okay.
Okay, which will become bk.
Okay, can. Sorry, my differentiation is rusty.
So this is actually positive, which makes sense because you look at the graph is positive gradient. Okay, it's always increasing. Okay, so yeah. Okay, so this is what you can do. Okay, now if you look into Desmos or something, you see that this is a very nice graph. Okay, so where's my Desmos now?
Where's our Desmos?
Okay, so yeah, this is Desmos. Okay. So you can see the gradient is different if you type in the equations. Okay, this is just this part. Okay, but if you take a look at the whole thing, the red color,
it's a straight line. Okay,
it looks like a straight line, but if you scroll out, oh shoot, what did I do?
Zoom out.
If I zoom out, it's not a straight line. Magic happened. Okay, this is not a straight line. It's no longer. Oh, why is it not moving? Okay, so it's not a straight line. It's this. But if you zoom in, back to this part. It looks like a straight line. Okay, so if I this, yeah, so
it's an illusion.
It's an illusion, exactly. Okay, so same goes to this. Okay, so if without this, it looks like a straight line, but when I put in and I zoom out, suddenly it's not a straight line anymore, and in fact it has two parts.
Very nice.
So go back
So,
here.
okay.
It looks exactly like what I just did.
So
Yeah, I
can
just
zoom
took
out
this
and show both graph again on Desmos.
both graph together.
Ah,
Yeah, so okay, I'll show the difference between these two lines. Okay, you can see one was what?
on Desmos.
238. Okay, the other one is 692. Wait, where's mine? I'm very confused. Too many tabs. Okay. So you see, two graphs are actually very different.
Because I remember you said they intersect very close to each other.
Yeah. Okay. So you see,
It's not the y-intercept, guys. If we zoom in,
yeah, the
they have
y-intercept is
different
quite close.
y-intercept.
Yeah. Okay, it looks very far. It's like 800. Okay, they are 30 units away, but in the midst of this big madness, the 30 units doesn't even matter.
Scale matters, guys.
Yeah,
That's the
matters,
takeaway from this question.
Okay. So if you draw the asymptote, you see that their difference just now, what x equals to some stuff. What's the number? 238 and 238, and also x equals to 692. Okay. So you can see this is their difference.
Yeah.
Okay. If I just take these two away, this black color line, and if I take these two, put this here.
This is the asymptote. Yeah.
There you go. Okay.
Yeah.
So what we want, actually, we don't need all this. We don't need all this. We just need this little thing here.
Because the boy is not going to blow the whistle for a few thousand seconds, okay? He cannot breathe.
He'll die.
He will die. So he will only blow the whistle for a short period of time.
So in general, if you don't know what the shape is, plot a few more points. And actually, I wrote it out here. Okay, just now, where was it? Yeah, here I wrote it out. Okay, you don't need to write everything out. You can just type in the calculator. It's quite easy to type in the calculator. You just change this to answer and then just keep on substituting different values. Okay, you can plot like 5 points if you just want to make sure. Maybe you get another point here, maybe you get another point here. That will look like a straight line. And similarly, maybe you can get a point here and get a point here.
Then just do your best guess of the graph. But generally, at this scale, a straight line is okay. But I think Mr. Samuel and I want you to know it is approximately a straight line.
Yeah.
Okay.
So yeah, my graph, I will actually make it curved, but it's very hard because it almost looks like a straight line.
Scale problem.
Yeah, scale problem.
Okay.
Anyway, so I hope that answered the question.
Yeah. Thank you so much, Mr. Samuel. And I don't know, maybe we'll see you in the next one, maybe not. Bye-bye.